All right. Now, let us look at the expression I have here. I'm going to zoom it in a little bit. I have an expression, right? 3a squared b plus 4ab squared. That is my expression because it is separated by a plus sign. Okay, so these are called terms, these two terms. And as I just said, they're separated by my plus sign. And let us look at the factors. So factors are the numbers that make up your term, or the numbers that you can divide your term by without leaving any remainder. So that's as far as it applies to numbers. But now we're dealing with variables as well. So factors just means what do they both share? So I'm going to write this down over here. What do they share? Okay, so if we look at our factors over here, I have a 3. A squared means I have two A's, an A and an A, and one B. And then on my other term, I have 4, an A, and 2 B's because we have a B squared. Okay, so I'm going to go ahead and highlight what we have in common here. And if you look carefully, I have 1A, 1A. Okay, and then I have 1B and 1B. Now, the others that I didn't highlight, there is no number that goes into 3 and into 4 without leaving a remainder. So we cannot regard that as a common factor. And here we have an extra A that we don't have on term 2. And here we have an extra B that we don't have on term 1. So those are not common factors. So for these two specific terms, my common factors would be A, B. Okay, now if we take out these common factors, which is what we're doing today. So you identify your common factors first, and then you remove them. So I have a 3a squared b plus 4ab squared. And I've identified my common factors as 1a and 1b. So what you are going to do is remove it or take it out. Okay, you're doing the opposite of the distribution law. So I'm going to take the AB out. Now, what is left over? How do we know what's left over, guys? You take your original terms, so 3a squared b, and you divide them by the factor that you just removed, which is ab. Okay, and then, of course, we have to simplify. So then, ab. So then, for the first term, I'll be left with a 3, 1a. And the rest of them are gone because they divide into one another. Do you guys see that? So the B will divide into the B, and the A will divide into one of the A's, but we still have one that is left. Hence, it is still in my bracket. And then with my second term, I still have a 4. The A's have canceled each other out, and the B's, I canceled out one B, right? But I still have one left, so then I'll be left with 4B, and we're done. If you're not sure, if you have factorized correctly, redistribute it and check that you can get back to the original question. Okay, so that was a lot of information, and I want us to practice now. So first thing is we're gonna check what our common factors are. So I'm gonna write you number 1. This is 3x plus 6. Okay, let's look at it. I have a 3x plus 6. Is there a number that goes into both 3 and 6? We can see there won't be any variables that are in common because 6 doesn't have a variable, right? But between 3 and 6, what factor do I have in common? Which number goes into both 3 and 6? A 3. Okay, so we have identified my common factor as 3. So I remove it from my sum or from my expression, And then I go and divide everyone by 3 to see what is left over. Okay. So then, my first term, the 3's will cancel out because it's 1 and 1. So I'm left with just x that was next to the 3. And with the second one, how many times does 3 go into 6? I know it goes into itself once, but into 6, it goes into twice. So what's left is a x plus 2, and you have factorized. Okay, guys, and if you times this back in, you're going to have a 3 times x, which is 3x, plus 3 times 2, which is 6. And that is what we originally started with. So this factorization is correct. Okay, guys. Let's look at number 2. 4x minus 8. What is my common factor in this case? What is my common factor in this case? I have a 4x and a negative 8. The diagram. Okay, here's the diagram. Okay, let me zoom out a bit if you want to take a screenshot. There we go. All right. So, as I was saying, 4x minus 8. What is my, thank you, 8. My common factor is a 4. So I remove my 4 from the two terms, which means I must go and divide both of them by 4. Minus 8 divided by 4. Okay. Now we look at the first term here. What happens here? The 4's have now canceled each other out. It's 4 divided by 4, which is a 1. And for the second one, what is 8 divided by 4? Negative 2. Nice slogan, because there's a negative here. So I'm left with an x here. I have a negative because there was a negative over there. Negative and a 2. So what I should actually be saying is, what is negative 8 divided by 4? Because the signs will affect your answer. And once again, if you go in times back in, that is 4 times x, which is 4x, and 4 times negative 2, which is negative 8. Okay. Let's do a slightly more challenging one. A slightly more challenging one. Let's do number 5. Let's go with number 5. It says 5ab plus 5ac. We're starting with numbers, okay? Is there a common factor between my two numbers that I have here? What is my common factor between these two numbers? 5ab, 5ac. It's a 5, so I can remove the whole 5, right? And now let's look at my variables. Which variables do they have in common? Which variables do they have in common? An A. Nice, Iminati. See? There's A there, and there's an A over there, which means this is my variable in common. So I'm going to remove it and put it there. Now, is there any other thing that they have in common? They have a 5 and an A. The first one has a B, but the other one doesn't. And the second term has a C, but the first doesn't. So they have nothing else in common. Now let me open my brackets, and once again, I'm going to rewrite them as they were 5ab, and I'm going to divide them by 5a plus 5ac divided by 5a. 5 divided by 5, what's going to happen to these 5's? What's going to happen to these 5's? They cancel out. Okay, so the 5's are gone. What's going to happen with the A's as well? So we also have an A, 1A, 1A. A divided by A, they also cancel each other out. A divided by A, gone. Okay, then we look at the second one. Again, we have a 5 and a 5, and an A and an A. Now tell me, on the first term, what do we have left over? What am I going to write in my bracket? What am I going to write? Nice. I'm going to write a B and then a plus C. Okay, be careful, Logan. You must write this plus that's in between. All right, so that's what's left over. And if you multiply them in, you'll see that you go right back to where you started. Okay. Let's go a little bit more challenging. Let's see. I'm going to go with number 6. 9ab plus 18a. Don't be sorry, Logan. We're working. We are learning, not working. We are learning. So don't be sorry. So this is 9ab plus 18a. Yes. All right, let's go with the numbers. Highest common factor between 9 and 18. Nice. So we have a 9. Okay. Common variables that they have. Let's say a. And then 9ab over 9a plus 18a over 9. I don't know what happened with that 9 over there for a second. Over 9a. Okay, first one, 9a and 9a. What's going to happen to the whole 9a? I have a 9a at the top and a 9a at the bottom. So I can divide them into one another, cancel them out. Now with the second one, my a's I know will cancel, but I have a 9 and an 18. What is 18 divided by 9? It is a 2. So I'm going to have a 9a. I know here what I have left over is a 2, but on my first term, what do I have left over? A b. So it's b plus 2. Okay, let's do one that's really challenging, and then I'm going to need a thumbs up, thumbs down from us, all of us. Okay, I want to make one up. Okay, I just want to see. So I'm going to say whatever number this is, I'm going to say 2x y squared minus 8x squared y squared. First thing that we need to check for before we even factorize, what would have been the first thing that we checked for here, guys? The first rule of algebra ever. You first check if they are like terms. So can we add those? Are those like terms? Are they like terms? No. So we cannot add them. If you look at the exponents, x there has a squared, but this one doesn't. So that disqualifies them from being like terms. So we know they're not like terms. Now let's look at my numbers. A 2 and an 8. What is my highest common factor between 2 and 8? It would be 2. Wonderful. Now let's look at my variables. I have 2 different variables here, okay? I have an x and I have a y. Let's first look at the x, okay? What is the highest common factor for x? I have 1 x there and I have 2 there. But how many do they have in common? Nice. So I can only take out 1x because you cannot factorize 2x's because this number doesn't have 2x's. There's only one. Okay. And then let's move on to the y's. How many y's am I able to factor out here? How many y's can we take out here as a factor? 2 of them, because they both have at least 2 y's. This one has 2 y's, and this one has 2 y's. So I can take out all 2 of them. Do you get it, guys? Now let's see what's going to be left here. I have 2xy squared over 2xy squared minus 8. Wow. Of course, I'm going to write it like that. I'm making fractions here. Teacher Cat, wake up. 8x squared y squared over 2xy squared. Okay. Now, what is left over for my first term? 2xy squared divided by 2xy squared. So what is my answer for that? It is not nothing. Nothing means 0, right? So is it 0? Do you guys think 0 is an accurate answer? No. Let's look. What's 2 divided by 2? It's 1. What is x divided by x? It's another 1. What is y squared divided by y squared? It's another 1. So what is my actual answer here? Is it a 0? It is just a 1. Do you guys see that? If I were to multiply this back in, this would give me 2xy squared times 1. And what's 2xy squared times 1? It is just 2xy squared, which is what we wanted in the first place. If you put a 0 there, then if you multiplied it back in, that would give you an answer of 0, which is not what we're looking for here. Okay, so it's a 1 minus 8 divided by 2. What's 8 divided by 2? That is a 4. Okay, now I have x squared divided by x. X squared divided by x. So how many x's are left here? Do we even have any x's left? X squared divided by x. What do we think? Nice, it's just 1. It's an x. And then y squared divided by y squared. It's like dividing a number by itself. So what happens? It's 1. Wonderful, guys. And that is our final answer. Okay, so after all of that, can I have a thumbs up, thumbs down on taking out a common factor? Before we move on, let me get some thumbs up, thumbs downs on taking out a common factor. If you are new, thumbs up, thumbs down means you go to your reactions and you give me one of these or one of these if you don't understand. Okay. Or you can send it in the chat. Or give me silly faces. All right. Great. Now, does this look familiar to you guys? Where do you recognize this from? Where do we recognize this from? Well, not yesterday, but the other day's classes, right? Now, how did we usually solve this? We split up the numerator and we put each one over the denominator, right? So we're not going to do all of them. I'm just going to do maybe C and D using this new method. So now one thing about algebra, guys, there are a lot of methods for a lot of things. Now you need to recognize this so that if you don't recognize which one you must use, you have choices, you have options. Okay, so 10, I'm going to do C and D in the new method of taking out a common factor. So I have a 10a squared minus 15a over a 10a. Now we're not going to split this up into two different fractions. We're going to take out a common factor in the numerator. Okay, do you see what the difference is between Thursday's class and this one? On Thursday, we had not learned this yet, so we split it up. But now I want to show you that you can also do this by taking out a common factor. Now let's look. Okay, I have a 10 and a 15 in the numerator. What is my common factor for those two numbers? What is my common factor for those two numbers? It's a 5. Okay, 5. Now, I have an a squared, meaning 2 a's, and just 1 a over here. So how many a's can I factor out? Nice, Bukhali. How many a's can I actually factor out? If I have 2 on one term, but only 1 on another, that means I can only take out 1. Okay, now let's talk about what's left over here. 10a squared over 5a minus 15a over 5a. This is all over. That was a terrible line. All over 10a. Now let's work this quickly. What is 10a squared divided by 5a? Let's start with the 5s, the numbers. 5 goes into itself how many times? It goes into itself once, and into 10 twice. Wonderful. 5 goes into itself once, and into 15 3 times. Okay, we've dealt with the numbers. Now let's look at the a's. I have 2 a's at the top, 1 at the bottom. Are there any a's left at the top? Nice, Iminati. There's only 1 a left at the top because one of these a's will cancel out with one of those. Right. But here I only have 1 a, 1 a. So what happens to those a's for my second term? What happens to the a's for my second term? A divided by A. They cancel out. They're gone. Okay. Now let's write what's left in this bracket. 5a, open bracket, 2a minus 3 divided by 10a. Now, what do these brackets mean? What do those brackets mean? What do the brackets mean, guys? We are multiplying, okay? So that means how many terms do I actually have now in the numerator? Remember, terms are only separated by a positive or a negative. So how many terms do I have now? Nice. I have 1 term, which means I can now divide this guy over here by my denominator. Do you see that? Do we see that? Now that we have 1 to remember, in the beginning, we could not just divide because there was a plus in the middle of nowhere. But now that my terms are in brackets, I have 1 term. So you can actually say 5a divided by 10a, and let us do so. What happens with the a's here? 5a and 10a. The a's, I have a over another a. The a's will cancel out. Wonderful. Now, between 5 and 10, what is my common factor? It is a 5. It goes into itself how many times? Once, and into 10 twice. That means if I have a 1 here, do I still need these brackets? It's 1 times the brackets. So do I still need the brackets? No. So that means my answer is 2a minus 3 over 2. Okay, so there are 2 ways to do this. You could have either split up the sum, or you could have just done it by taking out a common factor. Let's do D. 8p cubed minus 16p squared, all divided by 12p. Okay, now, what is my common factor between 8 and 16 in my numerator? In my numerator, my common factor between 8 and 16. It is 8. Okay, number is out. Okay, move on to the variables. I have 3 p's over here, and I have 2 over here. How many can I factor out? Amy says 1. Okay. How many can I factor out? Nice, Wade and Logan. They have at least 2. As in both of them have 2 of them. So I can factor out a p squared. Okay, I can factor out p squared because they both have a p squared. Do you guys see? I hope this is making sense to you guys. So you look at how many do they have, which will tell you how many you can factor out. It's usually the one with the least amount. So the least amount in this case is 2. So that means I can take out at least 2 of them. Now let's see what's left over here. I'm going to challenge you guys to do it without this dividing step. This one. No. This one. Okay. So first term, what's going to be left if I take out 8p squared? If I take out 8p squared, what will be left over? I took out the 8 and 2 p's. So what's left? Nice. 1p minus. Do you guys understand that part? I hope I didn't lose anyone. Do we understand why there's 1p left? Okay. Minus. Now, I took out 8 and 2 of the p's. Are there any p's left here? Bongo Musa says no. Okay. Bongo Musa, remember it was 8p cubed. And we took out 8p squared. What happened to the 8s? What happened to the 8s? The 8 that was there, you have not taken it out. So they have canceled. They're gone, right? And if I had 3 p's, which means I had p times p times p, and I have now taken out 2 of them, 1, 2, there's still 1 left. Do you see where this comes from? So the more you do it, the less you need to do the step. But for now, guys, just do that step. Okay, it's not a train smash. All right, you're welcome. Okay, now let's look at 16p squared. Okay, I took out the p squared. Are there any p's left? Are there any p's left for the second term? I have factored out p squared, and we had p squared. So do you guys think there are any p's left? No, so the p's are gone. Okay, we have established that. Now let's look at my numbers. Okay, out of 16, I have now factored out an 8. So what is left there? Out of 16, if I factor out 8, nice, Amy. It is a 2. Okay, when I say I factored out, that means I have now divided by 8. Okay. And this is still all over 12p. I forgot about that part. I was about to conclude the sum. I'm getting old, guys. 12p. Okay. Now, let's look at the factor I have now taken out and my denominator. 8 and 12. Do they have a common factor? They do. But what is the highest one? What is the highest common factor between an 8 and a 12? It is? Anyone? It is a 4. Okay, it's a 4. So how many times does 4 go into 8? How many times are we going to 8? Twice. And into 12? 3 times. Okay, we've dealt with the numbers. Now I have 1p at the bottom and 2 at the top. So this 1 will cancel with one of these. So how many are left at the top? It's just a p. So it's going to be 2p times p minus 2 all over 3. Okay. Now, as I'm writing this, I remember one of the biggest mistakes we make in tests. If you get to this answer, do not be tempted to times it back in. because you are undoing your progress, okay? So do not distribute now and then end up with a p squared again. No. Okay. At the end, when we're doing a summary of all expansions and simplifying, we will speak about the difference between those two words. What do they mean when they say expand? What do they mean when they say simplify? What is required of me? Okay. Let's have a thumbs up, thumbs down on what we just did. So you can either do this by splitting up the fractions, or we can do this by taking out a common factor. Nice. That's too few thumbs up, guys. There's at least 20 of us in here. I expect many more thumbs up than that. There we go. Much better. Much better. Okay. Now let's move on to the second part of this. The difference of two squares. Let's start with vocabulary. What does a difference mean? Mathematically, if I say difference, which operation am I working with? If I say difference, which operation am I working with? Difference. Let's have a quick revision. There's a sum, product, difference, and quotient. Okay, let's start with sum. What is sum? If I ask you for the sum of something, what am I asking for? Plus, you must add them. Okay, what is product? Nice slogan. Product is actually multiplication. Okay, so then what's difference? It is subtract. Okay, division is the quotient. Division is the quotient. So we need to remember this. Difference means a minus. All right. Now, for this specific factorization method, it has to be the difference. It is not sum of two squares. It is not product of two squares. It is not quotient of two squares. It is difference only. This is the only time when this works, guys. Okay. So if you look here carefully, I have something squared minus, which is the difference, something else squared. In this case, we're going to create two brackets, okay? And in my two brackets, what's going to go in is the square root of the first one, so the square root of a squared, plus the square root of b squared. That's my first bracket, né? And my second bracket is going to be the square root of a squared minus the square root of b squared. That sounds confusing, né? But I'm going to, let's look at the examples. Okay, so my example says 9x squared. Okay, I actually want to start with numbers before we confuse you with variables. If I have 4 minus 16. 4 minus 16. Let's create our two brackets so that I show you that it's the same as subtracting them. Let's start with just subtracting them. What's 4 minus 16? What's 4 minus 16? Negative 12. Okay, now let's do our method here. I have a 4 minus 16. Are they both square numbers? Can you find the square root of 4 and 16 without having a decimal? They have to be perfect squares. Okay, they have to be perfect squares. Yes, they are both perfect squares. Now tell me. So I'm going to have two brackets. I already know I'm going to have two brackets because A, they are both squares, and B, it is the difference of the two squares. So I know definitely I'm going to do difference of two squares. Now my first bracket, I said you're going to have the square root of your first number, which is 4, minus the square root of your second number, which is 16, or plus. It doesn't matter the order, ne? Doesn't matter the order. And the second one is going to be square root of 4 minus the square root of 16. Now, let's work this out. What's the square root of 4? 2 plus the square root of 16. 4, the square root of 4 again. 2, and this time it's a minus 4. Bracket number 1, what is 2 plus 4? We're in my first bracket. It's 6 and 2 minus 4. Negative 2. And what's 6 times negative 2, beautiful people? 2 times negative 12. Do you see that we get the same answer? It only works with the difference of two squares. Okay, now let's look at our two examples here. I have a 9x squared minus a 16, just a 16. Now, firstly, it's a difference, so I'm safe. We know 16 is a perfect square. 9x squared is also a perfect square. Okay, so you can either write it the way they did or the way I did. So how they write it is they rewrite it as a square. So instead of saying 4 plus 16, they will say 2 squared minus 4 squared. Because once you do this, you know exactly which numbers are going inside your brackets. Do you see that? And then you have your two brackets, plus and a minus. So the first one will be 3x plus 4. And my second one, 3x minus 4. Okay. Let's get to practice. Okay, it's very quiet, so I'm nervous. Let's look at x squared minus 1. X squared is already in its square formed. Minus, what's this? How do I change 1 to something squared? That's probably the easiest thing we can do. How do I change 1 to a number squared? It's going to be 1 squared. Do you guys see that? I'm going to close the rest of them. So now we know in my two brackets, I'm going to have an x and I'm going to have a 1. Bracket 1 is going to have an x plus 1. And bracket 2 is going to have an x minus 1. Done. Make sense? Let's have a thumbs up, thumbs down. We're awfully quiet. I am going to do many more examples, but let's have a thumbs up, thumbs down for now. Okay, I like the reactions I'm getting. Thumbs up, silly face, heart, smile. Ilham, where did I lose you? I feel like the 1 squared was maybe the worst example to start with because 1 squared. Let's do the second one, Ilham, together. Okay, you'll tell me after the second one if you're still confused. I'm going to say x squared, and the question was minus 4. Okay, the first one has already been written in its square form. It's x squared. But 4 can be written as what squared? 4, how can we rewrite 4 as a square? Nice, so it's 4 is the same as 2 squared. That means in your two brackets that you make, there's going to be an x and there's going to be a 2. Now let's make those two brackets. I said one of them is going to be a positive, so it's going to be this x plus this 2. And my second bracket will be the same x minus my 2. Okay. Ilham, how are you feeling now? I feel like the 1 was a little bit of a terrible example because 1 will just always stay 1. I'm going to wait for Ilham's response. Okay, we're back to unicorn. Wonderful. Wonderful. Let's do number 4. Number 4 says I have p squared minus 25. Okay, what is my base for the 25? P squared is already in its square form. What is my base for 25 going to be? So I'm going to say p squared minus what squared? 5 squared. Okay, so my two numbers in my brackets are p and 5. So we have bracket number 1, which is p plus 5, and bracket number 2, which is p minus 5. Okay, that's quite literally it, guys. It's literally just a difference of 2 squares. And then you take those 2 squares and you put the square roots in the brackets. Let's do number 6. I have 4x squared minus 1. Now, let's rewrite 4 in its square form. Rewrite 4 in its square form. Nice. So it's 2 squared times x squared minus 1 squared. Now, to fix this, do you guys remember the distributive law of exponents? I said those laws always work backwards as well. That means I can take out that squared to make it look nicer. As in, I can say 2x all in brackets squared minus 1 squared. That means, what are my 2 bases in the brackets? There's a first one and then there's a second one. What is the first thing I'm going to write in my bracket? Something minus 1 and something plus 1. What is that something over there? Nice slogan. 2x. Do we see it, guys? Now, the reason they have to be positive, negative, you guys remember foiling, right? You remember foiling? Where we multiply the first, the outer, the inner, and my last. The reason it's plus minus is because of the following. Let's multiply my firsts. 2x times 2x is 2x times 2x will give you, this is 4x squared indeed. Okay. Outer 2x times 1. 2x times 1 is just a positive 2x. Inner is 2x times negative 1. So 2x times negative 1 minus 2x. And last is negative 1 plus 1, which is negative 1. What's going to happen with these two terms in the middle? Positive 2x minus 2x. What happens with those terms? They are gone. So then I'm left with 4x squared minus 1. Do you see why it has to be a positive negative? And why it is a negative at the end. If this was positive, positive, it would just double. It wouldn't disappear. Okay, let's have a quick brain break. Is anyone who wants to speak to me for the brain break? Anyone? Ilham, let me unmute you. There we go. Hello.
Hi, ma'am.
Hello. Would you rather fall asleep during class or fall asleep during your lunchtime?
Fall asleep during lunch.
During lunch, is that what you said?
Yes, ma'am.
So you don't want to eat? Yo,
But if
guys.
you fall asleep during class, you're gonna miss out on what the teacher is explaining to you.
Yo, guys, for me, this is very difficult because I definitely want to eat. I most definitely want to eat. So the thought of falling asleep. Who said, Linomta's like, I'll eat at home. You guys falling asleep during class, so you don't want to learn. Hey, my gosh. Oh my goodness. Oh my goodness. The next one, would you rather have a fun teacher who is bad at teaching or a mean teacher who is good at teaching? So either someone who's fun but can't teach or someone who's really mean but can teach. Which one would you rather have? But Lala's like, I'd rather have a mean teacher. I want to learn. Yolanda agrees. Angel is like, I don't want either of them. Logan's like, I want 100%. And you can get it. Ah, everyone's saying mean teacher. So I must start being mean, ne? I must start being mean. I'm gonna say you guys told me I should be mean. Would you rather have an annoying but smart lab partner, like a group work partner, or a fun but lazy lab partner? So someone who's really annoying, like those people who like you really can't, but they're smart, but you really can't. Or a fun person, but who's lazy. Guys, remember the smart one won't let you do anything. Do you know the smart ones who are like, no, I'm gonna do everything. So you're just like, even your decisions are shut down. They're like, no, I'm doing it. You're still saying, Lishevel is like, sit and do nothing. Angel is like, no, I'll take the lazy. And the last one, would you rather be the best athlete or the smartest student? I feel like I know most of this for you guys, but let's see. I feel like you guys might surprise me. You know, I'm just like, I'm going partner. Butlalo wants to be the smartest. Is there anyone here who wants to be the best athlete? Oh, funny. Nice. I want to be a good athlete, but not the best one. It's okay if I'm not the best one. Okay, guys. Nice. Okay, I have a challenge for you guys before we close off our lesson here. Okay, I have a bit of a challenge. Now, I want you guys to take out the common factor for number 7. This was our last one, so let's put our all into it, okay? So number 7 says x. What do you see that is similar there by number 7? What do we see that is similar with number 7 in those two terms? What do they have in common? Bushevel says x, Bukhali says x plus 2 in brackets, which is very important. I'm going to reiterate again. Okay, let me talk about this whole term. Everything. How many terms are there here? I see a bunch of numbers and variables, but I want to know how many terms there are. Remember, terms are separated by pluses or minus. How many terms are there? Nice, guys. So there are 2 terms. Okay. So this guy inside is inside the bracket, so that makes it 1 term. So brackets like hug it and make it 1 term, right? These brackets. And because it's a multiplication here, it's still 1 term. Right. Now, what do these 2 terms that we just identified have in common? What do they have in common? Look carefully. See if we can identify it. An x plus 2. Okay, so what do we usually do with common factors? We can say x plus 2 is the common factor over here, right? X plus 2, that's my common factor. What do we usually do? We take it out. So I'm going to take it out. I'm going to say x plus 2. Okay, that means I'm going to divide, excuse me, with x plus 2 minus 5x plus 2 over x plus 2. What is left over in my first term? So this x plus 2 is on the outside. What is left over for my first term? Here. I have taken x plus 2 and I'm dividing it by x plus 2. Nice. I'm left with just x. And in my second term, what am I left with? Just a 5. Does that not look better? It's just more relieving. Right, so you can factor out also a common bracket. That's also possible. And be careful of common brackets, okay? Because if I say to you r x plus 1 and 1 plus x, common brackets, are those common? X plus 1, 1 plus x, is that a common bracket? I have a no from Amy, yes from Logan, no from Buhlali. What does everyone else think? Come on, guys. 1 plus x and x plus 1, is that a common bracket? Everyone else is just not answering. Logan, you are right. This is a common bracket. The order doesn't matter if it is a plus. Remember the analogy we did? If I say 1 plus 5, I'm going to get 6. But if I say 5 plus 1, I'm still going to get 6. So if you have such questions, be careful of these brackets because we will put them there as teachers. Okay? So you must see. You must just look at it carefully and be like, oh, we are adding and they're both positive, so the order doesn't matter. So x plus 1 and 1 plus x are indeed common brackets. So I'm going to end the lesson here, but if you want to do more of these questions that I now spoke about here, which is typical of exam questions, you need to come to the exam bootcamp.